Friends, today I am going to discuss some important concepts and formula of 1D infinite square well or 1D box you can say. It is very much important in case of quantum physics. It is playing an important role in the field of quantum physics. Today I will discuss some important formula of 1D infinite square well potential, 1D infinite square well or 1D you can say in one line. It's very popularly known as 1D box. Everybody says about 1D box. So what is the 1D box or 1D infinite square well? So let's start the discussion. Firstly, suppose you are drawing an 1D box. 1D box. It is x-axis one dimensional. Why it is called 1D box? Actually, name is something elusive. So let's start discussion. You all can say that why it is 1D box. It is a two-dimensional box, can be two-dimensional thing. Why we are saying 1D box? So let's start discussion. What is actually 1D infinite square well potential? Why it is called infinite square well potential? Some of you may say. So what is it actually? Suppose it is one-dimensional vertical ground, okay, horizontal ground, okay. Now you are drawing two. Here you are drawing a particle as free. A free particle. Free particle means what? That has potential equals 0. Okay. A free particle that has potential as 0. It is moving here and there. The particle. Let me change the pen color. Free particle. It is moving here and there. A free particle means what? Means free particle means potential is 0. Suddenly, you build a wall here to trap the particle here. You build two walls to trap the particle here, and here the walls are such that potential walls are infinite. V equals infinite. Here it is 0 to length L. Here it is 0. Here it is length L. Okay. So these potential walls are infinite potential wall. Suddenly you draw an infinite potential well so that the particle is being trapped in this well. Okay. That means what? A free particle that was moving here and there and it has potential 0, V equals 0. But you draw an infinite potential well to trap the particle is now trapped. The particle is now trapped in the infinite potential well. So why it is called infinite? Because here the potential wall, here the wall is infinite. Potential is infinite. V is infinite outside the box. Means suppose the box length is suppose L length box. So at the boundary of the box, potential is infinite. Yeah. At the boundary of the box, potential is infinite. But what is the potential of the particle? Potential of the particle inside the box is 0. So how can we define? First of all, whenever we define a system, we actually define the potential of the system. So whenever we define the potential of the particle or potential of the system, so potential of the particle is what? Free particle 0, but free particle inside that box only. So potential will be 0 only within the range 0 to L, means less than 0, less than x, less than L, means within that length of the box, but infinite otherwise. Otherwise infinite. Otherwise why infinite? Because see, here you have drawn that infinite potential well. That means here V is infinite. Okay. Here V is infinite. Here V is infinite. But inside the box, V is not infinite. Inside the box, what is the potential of the particle? Inside the box, potential of the particle is 0. So this is in general condition of the in 1D potential box or 1D box on the infinite square well potential. So it is actually the thing that it is a box where in the boundaries potential are infinite in the boundaries, and potential of what? Potential of the wall. Potential wall of the wall are the infinite, so that the free particle can be trapped inside that box, and free particle has a potential. Free particle has a potential 0 within the length 0 to x less than L. So now here I will discuss in more detail how many types of infinite square well potential are actually. Infinite square well potential, there are two types of infinite square well potential. Infinite square well potentials are of two types. One is symmetrical, one is asymmetrical. Symmetrical infinite square well potential and asymmetric square well potential. So let me discuss what is symmetrical and what is asymmetrical infinite square well potential box, so that you will be cleared. So symmetrical and asymmetrical. So whenever you are drawing an square well potential within 0 to L length, okay, here it is x-axis, here it is 0 to L. So here origin is at here 0, 0. Here origin is 0, 0. So within this length, here in potential infinite, here potential infinite, the potential of the wall is infinite. So within this length, what you are getting actually, within this length potential, within this length, inside this box, particle is trapped, and particle has trapped particle has potential V equals 0. So that's it. And it is asymmetric potential. Asymmetric, why? Why it is called asymmetric potential? Well, it is not symmetric. Why? Because with respect to origin, it is not symmetric. Because with respect to origin, it has only one side, it has only potential. Well, with respect to origin, it is not symmetric. That's why it is asymmetric infinite square well potential. But if we draw a potential well such that same length, okay, same length of the potential well, suppose draw an infinite potential well, same length, here minus L by 2 plus L by 2. Suppose origin is shifted here 0, 0, 0. So with respect to the origin, here I am just imaginary line. Don't imagine it as an wall or anything. Okay. With respect to this, the particle is symmetric on both sides. So this is symmetric potential, square well potential, infinite square well potential. But the length is same. But potential will be what? In this case, in case of symmetric potential well, potential will be what? Potential will be V equals 0 minus L by 2 less than x less than L by 2 plus L by 2 and infinite otherwise. It is very much important. Whenever in a problem, it will be given to you that potential is such that V equals 0 within minus L by 2 to plus L by 2, or anything within 8 by 2 to plus A by 2, whatever, anything. Then the potential is 0, and infinite otherwise, then it is symmetric square well potential box. Okay. Symmetric square well potential box. And if the potential is such that V equals 0 within 0 less than x less than L and equals infinite otherwise, then it is what? Then it is asymmetric square well potential. Okay. So this asymmetric square well potential. Now some important formula of this infinite square well potential, symmetric and asymmetric. What is the basic and actual difference actually? So whenever we are solving Schrodinger's equation, h cut square by 2m d2 psi by dx square, let me write. Whenever we write an Schrodinger equation, h cut square by 2m d2 psi by dx square, v equals 0, v psi equals 0, v equals 0. Actually, the particle has a potential 0, 0 psi equals 0, e psi. Then we will get the energy of the infinite square well potential as E equals, remember this, n square h cut square pi square divided by 2m into a square, length of the box. So this is the energy of the nth state actually. This is the energy of nth state of infinite square well potential, where A is the length of the potential, h cut is reduced Planck constant, you all know. N is the nth state. So for ground state n equals 1. First excited state n equals 2, such that. So here it is one important formula. You should know about this. So now we are coming to the points for the basic difference between symmetric and asymmetric. Whenever you will write the symmetric infinite square potential, means length is minus L by 2 less than x plus L by 2. Then what you are going to write the potential? Potential of the nth state will be root over 2 by length of the square potential cos, symmetric, I am saying symmetric, cos n pi x by length of the box for n equals 1, 3, 5, means odd values. Remember this is very much important thing. When n equals odd values, means 1, 3, 5 dot odd values, then the wave function of the symmetric square potential will be what? Psi n equals root over 2 by length of the box, root over 2 by length of the box. Suppose length is, here it is what? Length means L here. So here we can write root over, for n equals, for symmetric square potential n equals 1, 3, 5 dot psi n, nth state wave function will be root over 2 by L cos n pi x by L, where n equals 1, 3, 5. Otherwise, whenever n equals 2, 4, 6, whenever n equals 2, 4, 6, then in that case, infinite square potential wave function will be root over 2 by L sine n pi x by L. Remember, this is very much important thing that students students should remember here. Is very much important thing. We do mistakes actually here in case of writing wave function, because for symmetric means, see the range of the potential minus L by 2, see the range of the length of the box minus L by 2 less than x less than L by 2, that means potential is symmetric. Then psi n will be what? Root over 2 by L cos n pi x by L for n equals 1, 3, 5 odd values, and n equals 2, 4, 6 these even values, psi n will be root over 2 by L sin n pi x by L. Now remember another important thing, but when potential is such that Vx equals 0, 0 less than x less than L, or infinite otherwise, then what we should do? Then psi n equals what? Then psi n means wave function will be simply only root over 2 by L sin n pi x by L. Means there will be no cos for n equals 1, 3, 5 when the potential is such that potential is 0 to L. Means potential range is 0 to L. Then there will be only sign, n equals 1 to infinite, only sign. So this is the main important thing between symmetric and asymmetric box. Symmetric and asymmetric box, these are the main important things to remember. So actually, what is the ground state wave function of the infinite in asymmetric square potential? So whenever we will draw infinite square potential, the ground state wave function will be looking like that, 0 to L. Yeah, here it is the ground state wave function. Ground state wave function. Yeah, one important formula here you have to remember that whenever you are drawing the ground state means n equals 1, and it is asymmetric. Asymmetric means root over 2 by L, only sine. Asymmetric means only sine pi x by L. Here not cos for n equals 1. So ground state wave function means what? How to draw the graphs of the wave function. So whenever you are drawing the graph of nth state wave function, nth state wave function, for nth state wave function, the nodes, number of nodes will be what? Nodes of the graph will be n minus 1. Nodes of the graph will be n minus 1. Means for nth state 1D infinite square potential box, nodes of the graph will be n minus 1 number of nodes. N minus 1 number of nodes means what? Let me clear you. Whenever you are drawing n equals 1 means ground state potential means ground state wave function. Let me write here actually ground state wave function of the infinite square potential box. Then how to draw this? N means what? N equals 1 ground state. So number of nodes is what? Number of node is 1 minus 1 means 0 node. 0 node means now let you clear what is the nodes actually. What is nodes? Nodes actually means what? Nodes means actually whenever the graph is intersecting. Suppose you are drawing an arbitrary graph. Suppose here you are drawing an arbitrary graph. The graph is intersecting 1 times, 2 times. Graph is intersecting 2 times the box, not at the boundary. Remember, not at the boundary. Graph is intersecting 2 times the infinite square potential box. That means here node is what? Node is the number of node is here 2. 2 times the graph is intersecting the length x here, intersecting the box. That means number of nodes here is 2. Nodes is 2 means what? Here the probability of the finding the particle is 0. Means where the graph is intersecting the box, the probability of finding the particle here is 0. So this is a nodes concept actually. So for nth state wave function, so the number of nodes for infinite square potential is n minus 1 nodes. N minus 1 nodes means what? N minus 1 nodes is such that you are drawing, that is n equals 1 ground state, that means no node. You are drawing n equals 2 means first excited state. N equals 2 means first excited state of the infinite square potential. So how the graph will be? There will be one node. N equals 2 means n minus 1 nodes. N minus 1 means 2 minus 1 means 1 nodes. Here actually one node is here. This is the first excited state graph of the first excited state wave function of the 1D infinite square potential. Another important thing you have to remember that. So here one thing you have to remember. So when you are drawing the infinite square potential box graph, so you have to draw n minus 1 number of nodes. You have to remember the n minus 1 number of nodes. So now another important thing about 1D square potential box, that is whenever particle is such that 0 to a length, okay, 0 to a length, and the particle is such that you are finding the particle within 0 to L by 3. So what is the formula? Suppose in the question it is given that you have 1D infinite square potential box of 0 to L. Okay, 0 to L length you have that potential. So what is the probability of the finding the particle within 0 to L by 3? So now how you will do that problem? How will solve that problem? So first steps to do, so writing these steps to solve the particle within some certain range in the infinite 1D box. So first step to solve this is first write the wave function of the particle. So within 0 to L, what is the wave function of the particle? Remember what is it? The length is 0 to L means what is it? It is asymmetric. Asymmetric box means only sign is here. Root over sine n pi x by L. Okay. Root over 2 by L sine n pi x by L. And the probability will be what? Probability here you are writing, suppose 0 to L by 3. 0 to L by 3 psi star dx. Psi star dx. That means root over 2 by L sine n pi x by L, root over 2 into root over 2 by L sine n pi x by L dx. Just do integration of that formula. And a short formula that you can remember for solving this type of problem, the probability should be equals within the range x1 to x2, that will be 2 by L half into x1 to x2 minus sine 2n pi x by a into a by 4 n pi here x1 to x2. So this is a short formula. So another important thing, another important trick to find this probability is another important trick I'm now going to discuss. That is you should remember this thing so that you can solve easily. Suppose you are drawing 1D box. You are drawing 1D box 0 to L length. Divide this box into 4 parts. Okay. Divide this box into 0 to 4 in 4 parts means 0 to a by 4 to a by 2, a by 2 to 3a by 4, 3a by 4 to a. So I'm writing here. Suppose you are obtaining the probability of 1D box of length 0 to L length 1D box. So what is the probability for 0 to L by 4? Probability of 0 to L by 4, the probability will be 1 by 4 minus 1 by 2 pi. Okay. What is the probability within L by 4 to L by 2? Remember these things actually. 1 by 4 plus 1 by 2 pi. What is the probability within L by 2 to 3L by 4? L by 2 to 3L by 4, the probability will be what? Same, 1 by 4 plus 1 by 2 pi. And what is the probability within 3L by 4 to L? The probability will be same, 1 by 4 minus 1 by 2 pi. Now some important formula that is very much required to remember for you, that I am going to discuss that, sir. For asymmetric box, today I am going to discuss that for asymmetric box. In the next video I will discuss about the symmetric box also. For asymmetric box, average of x, expectation of position value will be what? Expectation of position value will be length by distance, length by 2. X average equals L by 2. And what is the expectation of x square? For asymmetric box, expectation of x square will be, remember this formula, these are very important formula, a square by 3 minus a square by 2n square pi square. So x for 1D asymmetric box means 0 to L length, x average equals a by 2, x square average equals a square by 3 minus a square by 2n square pi square. Similarly, for 1D box, what is the expectation of P? For 1D box, infinite asymmetric soil potential, psi is what? Psi is real. Psi real means what? Psi real means expectation of momentum. Momentum expectation is always 0. What is the expectation of P square? P square expectation is n square pi square h cut square by a square. So it is a momentum square expectation value, P square equals n square pi square h cut square by L square. Similarly, for symmetric box, if we do expectation of symmetric box, expectation of x for symmetric square potential box, x average equals what? X average equals 0. X square average equals what? X square average equals a square by 12. Remember this, a square by 12 for minus a square by 2n square pi square. P average same, momentum are real, momentum wave function is 0, and P square average is also same. So this is the things for today. Remaining some important problems of 1D box I will discuss in my next video. Thank you for patiently watching. Actually, I am bringing this series for you. Actually, 1D box is very much important, and some students don't understand the concepts clearly about this. I was also one of them. So I'm trying to bring such new things for you guys in the freely. So thank you for patiently watching. Bye.